My name is Tess.
My name's April.
And our third group member is Zoe. Our question is, if we test 10 sodas, how will the grams of sugar, pH, and price affect the amount of bacteria that's in the soda? So if we test 10 sodas with our negative control as water, then we think that the more sugar in the soda, the more bacteria there will be, because bacteria feed on sugar. And the closer the pH of the soda is to 7, the more bacteria there'll be, because bacteria survive best when the pH is at 7, and if the pH either goes down or up from there, then they'll die, because it's either too acidic or not acidic enough. And we also think that the more expensive the soda is, then the more bacteria there will be, because the more expensive sodas are more natural, so they use less chemicals that would normally kill bacteria. As you can see, we expect that as the sugar goes up, then the percent of plate covered by bacteria will go up too. And as the pH gets closer to 7, then that will go up too. Or also if it goes down on the other side of 7, that will go back down. And as the price gets higher, there will be more bacteria.
This is our combined research paper. Our introduction basically says the reason we want to do this experiment is to find out what's really in soda, because people are always talking about how soda is so bad and stuff like that. And so we want to know what kind of bacteria is in it, and maybe what we find out could lead people to choosing a healthier soda. Our first body paragraph is about bacteria in liquids and phosphoric acid in liquids, which is an acid that they put in sodas to kill bacteria, and also it gives it a crisper taste. Our second body paragraph is about aluminum cans and making of aluminum cans. Goes through how people make them. Our third body paragraph is about Coca-Cola and other sodas that Coca-Cola owns. And that promotes Coca-Cola a little bit, but it also gives the ingredients in Coke, talks about other Coke products. This is our conclusion. What we want to find out is how much bacteria there is in soft drinks, and we think that sodas like Coke and with higher amounts of phosphoric acid will have more bacteria, or will have less bacteria, which sounds good, but phosphoric acid is actually really bad for you. So it's kind of a tricky subject because you may want to drink soda with less bacteria, but that also means that it has lots of phosphoric acid,
Which is really bad for you.
Our bibliography, the websites that we used were CBS News, Associated Content, Coca-Cola Company, and Answers.com. Here are the materials. The sodas that we needed were Izzy, Diet Coke Plus, Diet 7-Up, Whole Foods Raspberry, Coke Cherry Zero, Hanson's Cherry Vanilla Cream, Diet Barb's Root Beer, Diet Dr. Pepper, Diet Coke, Diet Pepsi, and water. We also needed a camera to take pictures of the plates after they'd grown bacteria. We needed plates with media on them to grow the bacteria. We needed Q-tips to test the soda. We needed test tubes to store the soda in. We needed parafilm, which is like a tape that you tape the bacteria, which you tape the plates with. Then we also needed a beaker to heat up the media. What you need to do for this experiment is warm media in the beaker, label plates, pour media into the plates, parafilm and put in an incubator and wait for bacteria to grow. How you incubate is you take the test tubes and you dip the Q-tips in each kind of soda, and cover their portion of the plate in that kind of soda. Then you put the soda back, cover the plate in parafilm, and put the soda back in the fridge. And recording data after 3 days. Observe the plates. How we observed the plates and counted the colonies was by calculating how much of the plate was covered by bacteria, and then we recorded the data in graphs and data tables. This is the data table. These are the data tables. As you can see, there was kind of a large range from 23% to 2%. Diet Coke Plus had the most bacteria, and Diet Dr. Pepper had the least. And the pH level, sugar, and prices vary, as you can see. These are our trials. Trial 4 seemed to have a lot more bacteria, which could be because the plates got contaminated while we were doing the trial.
But we're not quite sure.
Here are the pictures.
So in some of these pictures, the bacteria is a little bit hard to see, but as mostly from trial 4, you can see like almost the entire wedge in the plate is covered by bacteria. We also have some like orange spots and another big glob there. And here are the final graphs. So as you can see, most of our variables didn't have a huge effect on bacteria, but price, it did go down as the soda got more expensive. Not quite as much as we had expected, but it went down by like a couple percent. So it basically fit in with our hypothesis, but not to the extent we expected. Is in sugar, the bacteria actually went down as there grew to be more sugar, which was totally not what we expected. It didn't go down by that much as in price, but it did go down, so our hypothesis was really wrong. And in pH, it actually fit in with our hypothesis. The amount of bacteria spiked, though just a little less, around pH 5, and went down on either side of that. So basically, most of our predictions were right, but none of them had a very large effect.